We need to talk about solids, liquids, and gases. We need to talk about how they behave and what they look like. Solids are in a nice, orderly shape, okay? And if I put a solid in this container, it's going to hold its shape, okay? Liquids are also tightly packed together, but they're not orderly, and they can slip by each other. Okay, and they do, if I put liquid into a cup, it takes the whole shape of the container. And they're moving. These guys are moving too. They're just vibrating. Okay, so all three of these states of matter have movement. Vibration. Whoop. Liquids are slipping by each other. We'll just say slipping. Okay, and gases have a fast, random motion. And they will take up the entire container, but they will have a lot of space between them, and they will be bouncing all over the place. Okay, these guys will just be vibrating in place, and these guys will be moving, slipping by each other a little bit. These guys are going crazy. So, the energy. Let's think about this. If you were sitting in place on a couch, you would have very little energy. So this has low energy. And we're talking about the same kind of solid. Okay, so the same element. Now, if you started moving around a little bit more, you would have more energy. So we have low energy here. And we're going to just say medium energy. And if you're a gas and you're bouncing all over, hitting the walls, bouncing off the walls, we have high energy. So what happens with our energy? I need to gain energy to go from a solid to a liquid. And if I go from a liquid to a gas, I am moving faster, so I need to gain energy again. Going the other way, going from here to here, I lose energy. And if I'm going from a liquid to a solid, I'm moving slower, so I am going to lose energy. Okay? Now, are they compressible? Well, these guys are packed very tightly, so no. If you had a solid, you probably couldn't compress it. Now, some of you guys are going to say, I can compress a foam ball, and a foam ball is solid. That's true. But inside the foam is little air bubbles of gas. So you're really just compressing the gas, not the solid matter. Liquid, again, not space between them. They are not compressible. Gas is compressible. Let's put yes. Yes, it is compressible. Okay? And you guys actually know this. Okay? When you have a party, you might use helium balloons. Helium balloons are filled using compressed helium, and you can get a little party ball, and it's tiny. It's about the shape of maybe a baseball, and you can fill about 100 balloons. So that gas was compressed, you let it out, and it takes up much more space when you fill those 100 balloons. Dense. We're just going to compare the densities. What's most dense? Well, density is how much matter is in a certain space. So how much crap can you fit into a room? If it's packed tightly, you can fit a lot of crap in a room. So this is very dense. Okay? And then if I go this way, I get less dense. Gases need a lot of space between them. I can't fit a lot of gas particles in this room because I need all this space, so it's less dense. Kinetic energy, that's about motion. Okay, I have low kinetic energy, and it goes to high kinetic energy for my gas. And shape and volume is about, can they take the shape of the container? Liquids can take the shape of the container. Gases can take the shape of the container. But if I put a block into a cup, it will stay in this cube. It will not take the shape of the container. It won't fill up the whole volume either. The volume of liquid, if I have 10 milliliters, it doesn't matter if I spill it on the floor or put it in something else, it will still be 10 milliliters. Gas is very different. Gas will expand to fill the entire volume. If I make the volume bigger, the gas will still expand to fill up the whole volume. How do you know this? Well, if you open a perfume bottle and I open it, probably people across the room can't smell it. But in an hour, everybody will smell it because those particles filled the entire room. Okay? So now we're going to talk about phase changes. Okay? So when we talk about phase changes, I want you to think about water, and that will help you remember these things very easily. So if I go from a solid to a liquid, I have ice and it goes to liquid. What's the name of that phase change? Well, the ice melts, right? So this is melting. What if I go from a liquid water and I go back into that solid ice cube? What happens? That's freezing. So you already know most of this. Now, there we go. Sorry, running out of pencil lead there. Gases. If I take a liquid and I go to a gas, you are going to vaporize. So it's vaporization. Okay? And this could be boiling is one type of vaporization, or evaporation. Okay, so these are the two types of vaporization. Boiling, as you know, if you boil liquid, it will turn into a gas. Or if you have a puddle on the ground, that puddle will go into gas. It will disappear, and that's what's going on. What about if I go from a gas and I turn into a liquid? So think about your ice cold cup of water on a hot sunny day, and there is, in the air, there's humidity, right? That's gaseous water. What happens on the outside of that cup? Well, that gaseous water hits the cold cup, it slows down the particles, and it turns into condensation on the outside of your glass. So this is condensation. Okay? If we go from a solid straight to a gas, that would be the dry ice that you might see at concerts that make a fog, and that's called sublimation. Okay, and something no one ever really talks about, but if a gas turns into a solid, that's called deposition. Okay, so these are the notes that you will need to have to do your worksheets.